Mm. So this is the first session. So we'll wait for 5 to 7 minutes for the participants.
Hello, sir. Am I audible? Hello.
हाँ फाल्गुन जी, how are you?
Sir, good afternoon. I'm fine.
Good evening, Dr. Falgun.
Ma'am, very good evening. How are you, ma'am?
Fine, fine. How are you?
Me also, ma'am. Fine.
Mm.
Sir. Sir. Rohit, sir. Ma'am, તમે કેમ છો? બહુ દિવસ પછી મળ્યા સર આપણે કેમ?
હા સર બહુ એમ થઈ ગયો.
બાકી એ જ સર કે આગળ કોઈ મળે ને સર.
સર બહુ બધું કામ ચાલે છે બહુ બધું.
ગ્રેટ.
ડોક્યુમેન્ટેશન એટલા બધા છે ને કે વાત ના પૂછો. કારણ કે હેલ્થ કેર છે ને એપ્રુવલ લેવા પડે ને હોસ્પિટલમાં.
ઓથેન્ટિકેશન ઘણું
રેગ્યુલેશન એટલા છે કે એટલા ફોર્મ ભરવા પડે, એટલા કન્સર્ન લેવા પડે, બધી means ઘણા બધા રેગ્યુલેશન એપ્લાય થાય છે એટલે
So your main task is to create the database, is it? Or any other things?
no ma'am, we develop the health monitoring system
Okay.
using AI.
Okay, okay.
So ડેટા કલેક્શન થી લઈને બધું આવી જાય, ડિપ્લોયમેન્ટ સુધી બધા સ્ટેપ આવી જાય.
તો એ તમારી કસ્ટમાઇઝ સિસ્ટમ હોય છે.
યસ મેડમ, કે મીન્સ અમારું એવું છે કે મીન્સ અમે અત્યારે પેન પ્રોજેક્ટ પર કામ કરીએ છીએ કે મીન્સ કોઈને પેન થાય છે તો એનું મોનિટરિંગ સિસ્ટમ કે પેન કોઈ પેશન્ટને પેન ફીલ થયું તો ડાયરેક્ટ ડોક્ટરને ઇન્ડિકેટ કરે કે ધીસ પેશન્ટ ફીલ ધ પેન. સો ત્યાં એ લોકો શું પ્રોસિજર કરવી પછી એ લોકો એના ઉપર ડિસાઇડ કરે. કારણ કે હર વખત તો કોઈ વોર્ડની અંદર ડોક્ટર ઉભો ના રહી શકે. So we try to monitoring that using AI. So AI tool બનાવવા માંગીએ છે. Means ડોક્ટર સ્ક્રીન ઉપર ડાયરેક્ટ.
So you are a mediator between the patient and the doctor.
Yes ma'am. Telemedicine application ઉપર કામ કરીએ છે.
Okay, so do you have a collaboration with the doctor?
We have one collaboration over here, means one university, medical university in Munich, and that doctors are means, so we working in the two projects. One is the pain and second is the fracture monitoring. Means once we get the fracture, so we try to develop this software which assists you to your fracture healing process. Means you don't want to go to hospital. Means you can do on your home that thing.
Okay, okay.
Listen, angle, they measure the angles of your joint. Means in all, means so the,
Oh, but for that one need to have an X-ray, I think.
after X-ray, once we done the X-ray, then they check the movement, how your head is moving after the treatment.
Okay.
For that, you need to go to hospital for every week. So
I think checkup itself will be carried out by system, right?
yes.
Again, when after around 21 days or so, I think so need to reach to hospital for X-ray.
No, sir. Means X-ray is they will do the treatment. After treatment, they do one procedure.
Correct. So I think system is giving surety that after 2 months or 1 month, the things will be fine.
Yeah. Means you also not go for 1 month after that. Treatment is done.
Oh, okay. Great.
Directly assist you using the software.
So, along with the suggestion by system, doctor suggestions will also be there.
Yeah.
So are you going to cover such things in the lecture?
And lecture I cover the cancer software which is already in clinical trial right now.
Okay.
And how we done that thing. I will show how that thing in last. What is our output and that methods.
Okay, okay, fine. As we have a 3 back-to-back session between 5 to 8, so we'll not waste much more time. And while participants is joining, we'll start the day 3. Very warm welcome to one and all present in the first session of the day 3. And today's our session chair is Dr. Falgun Thakkar. So he will be handling this first session. So now mic is handed over to Dr. Falgun Thakkar.
Thank you, madam. Invite me. Here, I welcome one and all in the Signal School of Multidimensional Signal Processing Tools and Technology 2022. The program is of 3 days. And of course, over here, it is matter of proud that we are also having our chairman, Dr. Chirag Pawala. Along with that, we are also having faculty coordinators, Professor Nita Pawala, KP Pathak as well as Professor from this side. Now, it is also a matter of proud that we are having AM expert, slide 2. So now, without wasting more time, let me introduce Dr. Thanki by means of your words. So Dr. Thanki is a computer vision expert and AI researcher with over 8 years of research experience in computer vision, artificial intelligence, medical image analysis and security, biometric as well. He is currently working as a data scientist in KRiAN, Germany. He earned his bachelor in electronics and communication, master's in communication, as well as doctorate degree in digital image processing, along with the data security. His area of research interest are medical image analysis, artificial intelligence, machine learning, deep learning, digital watermarking, data security, compressed sensing, as well as signal processing. He has more than 40 publications to his credit and also contributed more than 20 books with different publishers. And other than this, in my knowledge also, there are many other domains in which Dr. Thanki is right now working with very much huge experience of the detailed tasks. Right. So now I would like to call Dr. Thanki to present his expertise with our participants. So let me hand over to Dr. Thanki, please.
Thank you, sir. Can you see my screen?
Yes, screen is visible. Yeah, thank you, sir.
So I can start. So yeah, means today I speak on the medical image analysis using artificial intelligence. This is a very vast subject, and right now there are lots of research is going on this area due to the COVID pandemic. Because after the COVID pandemic, the many industries and also the government are thinking on the revolution in the healthcare. So this technology is used to fulfill some gaps in the recent healthcare system, because there are very open points in the healthcare system, like shortage of the doctors, shortage of the experts in terms of the surgery, in terms of the prediction of the disease, and so on. So this technology, it will be the future technology which helps the doctors to make some decision better, and also reduce the time to treatment. So in this lectures, I try to cover the various type of medical imaging techniques along with the artificial intelligence, and how means using some retinal image use cases, how we use this technology for the in the healthcare. And in last, I saw how this breast cancer can be predicted earlier using the AI, which is already in the clinical trial right now. So in this talk I cover the medical imaging along with the AI and the machine learning. So and then use cases of that. So first of all, what is medical imaging? It's nothing but the process which helps the physician to see the inside the human body, means which is not visibly seen by the human eyes. So and these processes are used in the clinic and for the clinical to assess the human body. In the industrial, we also use this some medical imaging techniques over there, like ultrasound, where we have to try to find out what is the problems in the some areas. Like I can say, in the we use X-ray ultrasound to check the quality of the product or the material in the industry. So this is the imaging techniques. So why we require this? Because first of all, we for some type of treatment, we cannot assume or predict using the human, means without seeing that object or that organ. So for that, researchers are coming with the idea to see the imaging or the inside the body. So they develop this technology. That the main disadvantage of this to find the subject to interpret, how to interpret this object which is seen on the image, which is produced by the computer manually. So this is the one drawback, because human has a very limited interpretation ability to analyze the data. So this is the origin of this medical imaging. Now these are the medical imaging techniques that are used in the clinic right now. The radiographs is nothing but the X-ray. Computed tomography means CT scan. Then the magnetic resonance imaging is MRI, ultrasound, and mammogram. Mammography or the mammograms is a particular imaging techniques which is used in the breast cancer. So these are the majorly techniques which is used in the medical science. Now radiography. So X-ray is everyone know about the X-ray. So radiography is nothing but the X-ray. The X-ray is nothing but one type of the lights which so when you pass the X-ray to your body and capture that ray on the one on the film, you get some objects of your body, and this is widely used in the medical science because it is very cheaper and very easy to generate this type of images. And this X-ray is used into most of the cases to detect the skeleton system like the fracture or the bone breaks of that identification of that all the stuff. We use X-ray. X-ray is also used for the lung diseases, and in COVID, this thing is widely used because we saw the lots of research using X-ray images and to predict the COVID or not COVID cases using AI. So after the COVID, this X-ray for the lung cancer and the lung disease identification are widely used. Then the second type is the CT scan. This is also called the computed X-ray tomography. This is used in the detection of the, which is used for the detection of the cancer. CT scan are mostly 3D images, and using and most we convert the 3D images into 2D images for the processing and the diagnosis of the disease. This tomography is a word of the two bricks work like tomos like slice, and the graph is a discussion, slice discussion. So in the CT scan you get the slice of the images like if there is 60 fps means I get the 16 slides per second, like that type of images we get in this imaging using these imaging techniques. Now the CT scan is where the CT scan is used. CT scan is usually used for the cancer diagnosis most of the time, and also they use in the different disease prediction as per the requirement of the as per the suggestion by the doctors. So this is not a specific application where we can use CT scan because nowadays CT scan is used in various disease prediction. So this is expensive than the X-ray. And next is the magnetic resonance imaging. This is also the one type of imaging techniques which is find the live movement of the object. So and how the water is flowing in the particular area in your body. So for that we use this technology, imaging technology, to describe that thing in the human body. So this is used to obtain the two-dimensional view of the internal organ of the human, mostly using the brain tumor and the spinal cord. Means when this is or the prediction related to brain or the spinal cord, then these imaging techniques are widely used over there. Also, this is used in the cancer chemography therapy response checking, and also used in some fractures treatment like the bones and joints examination. Now, ultrasound. Many ones know about this ultrasound imaging, because this is also one of the famous imaging techniques. So in this, we pass the high frequency sound wave to the area of interest. Area of interest in terms of the body means organ, like various organs. We pass this ultrasound and capture the returning echo and generate the images in the ultrasound images. And this is used in the most of the case in the gynecology, cardiology, and the cancer detection. In the breast cancer, this is a useful technology, and this is similar to the X-ray, but give the fast results compared to X-ray. Now, this is a new mammography. Mammography. This is a new imaging technique which is particularly used for the breast cancer. This is the low dose X-ray images which used to examine the breast of the woman for the breast cancer prediction. And this is for this which is dedicated devices are coming, because the normal X-ray cannot capture the mammogram or mammographic images. So this part of the various images. So you have anyone any doubts up to here? I can explain the things. So now I move on to the second topic, is AI and machine learning. So they because how the AI and the machine learning is useful, and what is basically AI and machine learning. So this is nothing but a computer science branch which try to build a smart machine which is capable to human like performing the task like human being without the interference of the human intelligence. Or otherwise, I can say that AI is nothing but we try to develop a computer brain which can work as a human being, or means they can be working like some task which human cannot be performed. So using the intelligence of the human, we try to build a system which can be useful for the human society. This is the AI. When AI is a branch of the data mining, where AI is divided into machine learning. The machine learning is nothing but we try to learn the machine using various computer algorithms. So and that there are various type of tasks we can perform using machine learning. One, the classification is nothing but we have to divide the two different classes. Like I can take the simple example like dog and cat. So we try to differentiate any unknown images of the dog and feed that image into the classifier, which gives out the class. This image will be a dog, something like that. Regression means we also one type of classification where we get the continuous output, like prediction of the values in the share market, where we use the regression. And clustering means we try to grouping the same types of classes of the data in the multiple class data. If I have the three different data in the one data set, like one is age, one is gender, and third is means country. So I can group that all this data in these three classes, like age, gender, and the country, like that. And density estimation, which is used to find the distribution on the data, means which data has the highest distribution in that. And the last, the dimensionality reduction, means sometimes it's not possible to process all the data because we're dealing with big data. So for that, and sometimes in the data there is some similar pattern over there. So you can using these techniques you can reduce that data, or reduce that redundancy in the data using this dimensionality reduction algorithms. This is the uses of the various tasks we can perform using the ML. Now, this is the basic two types of the machine learning. One is supervised learning and second unsupervised learning. So I can say supervised learning means the classification, where we have classified different classes, and the unsupervised means we try to group the same type of data into one group. What means like this is the unsupervised learning. And in the healthcare, unsupervised learning we basically used to identify the detects means the tumor or the organ in the image, or the means better diagnosis. Because in the human body, there are many organs over there. So sometimes you have to identify which organs over there, or which organ you want to show in your image. So using these techniques we are learning, or this algorithm, based on this learning we can detect that thing. Then this working flow of the unsupervised learning. Over here, we have only feed the first we have the data which can be anything like the images, documents, like the videos, any data. We try to find the important features of that data and feed that features into the machine learning algorithm and train the model, which is this is called as AI trained model. And using that models, we have to give the unknown values over there, like the text or the document, or which type of models you means develop. Like you develop the AI models for the data prediction or the means prediction of something. Then we have to give the similar unknown data of that means prediction value over there, and try to predict what is my output, like which give me some cluster ID or what is the similarity between the input data, means unknown data, and the trained data. That type of output you get as a in the unsupervised learning algorithm. Now this is category of this learning and the algorithm. First is the clustering, where most of the know about the K-means and the fuzzy C-means. These are the examples of this learning category. Then the density estimation, where we use the Gaussian mixture model, and third is the self-organized map. This is also one of the unsupervised learning algorithm which is used to group the data or the used for the clustering. Now, second type of learning is supervised learning. This is widely used in the practicals because we try to classify the various applications, or we use the classification in various applications. So for that we use this supervised learning, where model try to learn from the previous information which we give to that with the labels. And this learning and also divided in two types. One is the classification, and second is the regression. And in healthcare, we use this for the classification of the normal images and the abnormal images, means image with some disease or some problems in that image. Or the means, like I can take the example of cancer. Then we have to use classification to find the normal image and the image with the cancer, like that. And over here, only one change is that with the data features, we also give the labels of that features to train the model. Where in the unsupervised, we only feed the features of the data. Over here, we also add the labels and generate the AI trained models. And based on that models, we as an AI, we give the unknown values to that model and expected the labels. Like in this, we get the output like what is the input image or what is the data we have entered in the AI trained models. The labels would be like dog, like cat, something like that. That's what your input. And these are the supervised learning algorithms, which can be classified in categorized in a different way, like linear classifier and the parametric functions, where we use the probabilistic functions to rewrite the algorithm. Then the non-parametric, then non-metric, and then these are the 5 algorithms types we can use as per our requirement. There are no any from rule to decide which algorithm will be suitable for the which application, because these are all the algorithms are most of the times give the same outputs, but the processing time and the learning time of these algorithms are different according to the input data. Now, second is the deep learning. This thing is very used nowadays in the practical approach. This is nothing but the extension of the artificial neural network. The artificial neural network is very old computer algorithm. So this is nothing but the extension of that. In this deep learning algorithm, we use they consist of the different layers over here. The input layers, then the evidence layers, and the output layers. And each layers are connected with each other and give the prediction of the output as per the previously generated results of the last layers. And the main difference between artificial neural network and deep learning. In artificial neural network, we have only one hidden layer. Over here, we can have more than two or more than two hidden layer over here. That is the basic architecture of the deep learning. Like the input layer where you have to give the inputs. Hidden layer, there are lots of hidden layer over there, and output will predict the outputs based on these weightage values and the inputs layers in the hidden layer. There are lots of processing done over there, and based on that weightage value and this input layer values, we get the output. This is a famous neural network, and this is widely used in the image related problems. Convolution neural network. This is the in this there are two major sections. One is the feature extraction, and second is the classification or the classifier. So in the input layer, first of all, we try to find the features using this convolution function, which is nothing but the partial filtering of the image. So we use some filter mask over there, and based on that, we try to find the important features from the images and get the features of that after the So after that features, we convert the features into the factor which is suitable for the classifier. So we use the pattern which convert these features which is into 2 dimensions, which we convert into vectors, and that we have give as a input in the fully connected layers, where we have the different neural network over there which generate the weightage value, and based on that we get the output layers where we use some activation function. In the classification, we mostly use the softmax. So based on that probability which we get the output layer, based on that probability we get the predicted output. Means I can take the example of the 2-class classifier, means cat and dog. If my features value is higher than 50% or 70%, and I make that 70% label as a dog, then I get the dog is output. And the below of that means this is output layer where we can put the logic how you define your classifier. Means if your output layer value is less than 50, you can show output is a cat. If the output value is greater than 50, you can say see that output is a dog. Like that, you can put that programming over there. This is the basic operation over there. This is matrix operation which is performing in the CNN, where the convolution is nothing but we have the image matrix and the filter mask which generate these convoluted features, and then ReLU function which try to, if there is a convoluted features, the negative values over there. So this ReLU functions, ReLU operator is remove all the negative values in the output and give the only output with the positive value. And the pooling is try to reduce the dimension, because if this because we also have the limited computational power, so for that we use this pooling operation to reduce that amount of the data which is generated after the convolution operation. These are the basic operations which is performed in the feature extraction area, means part of the CNN. And the classification, I already explained these things, how this works. Now, next point is the AI in healthcare and medical imaging. This is where I can give what is the AI, why we use AI in the healthcare. The AI is used in the healthcare for the interpret, analysis, and the visualization of the medical data using various algorithms. Because and the main aim of this application to analyze the relationship between the diagnosis and treatment method and conclusive decision. So using this AI, we have to try to find out what is the relationship between the diagnosis methods, and how the treatment will be performed, and how based on these two, how we give the conclusive decision about these methods. And so these are the applications in the healthcare where the AI can be useful. One is maintaining the healthcare data. Second is the designing of the treatment method. Third is the virtual nurses development, like then what is the medication management, drugs creation, precision medicine, health monitoring, and healthcare system analysis. So, and most of the right now, the most of the industries and research teams are working on the creating the health monitoring system and the healthcare system analysis. So these are the application of the and of the AI in the healthcare. Now, there is also the particular application of the AI in the medical imaging. So doctors have been using the medical image techniques to identification of the disease like cancer for many years, and AI can improve that processing using medical intelligent image analysis and help to improve the patient diagnosis. And right now, the many companies and the many companies are coming with showing some solutions which shows that AI in the medical imaging have a very good usefulness, and also it will be give the better result compared to doctor's prediction sometimes. And these are the applications of AI in the medical imaging field. Like they using that we can automate some prediction, also increase the productivity. Means we can increase the number of cases diagnosis in the day. Like right now, doctor can predict the 10 or the treatment 10 cases. Using this prediction, that can be it can doctor can be done or the treat 20 cases, and then with more accurate diagnosis we can achieve using AI, and also the technology will be accessed to the doctors to make the better decision. Now, the medical image analysis using AI. Over here, I saw some use cases using some retinal image analysis. Also, I saw the example of how AI is used for the breast cancer prediction. So, mostly AI is used in the medical image analysis for image classification and image segmentation. So, these are the two major example area where the AI is useful. Now, I take one use case, the retinal image segmentation, where I using the ML approach. So I saw the how unsupervised learning algorithm can be useful to segment the medical image. So for that, I take the input medical retinal image, which is used in the treatment of the glaucoma and the diabetes. So it is a retinal conducive image, and I identify the ROI using the doctor's knowledge, because we get this image from the doctors and then try to extract the ROI using the image cropping operation first, and then based on the image color image processing and the ML, we try to segment the area which is useful for the prediction. So in the glaucoma, the doctor side try to find the CDR curve to this ratio. So we have to try to find this curve and this in the retinal images. So first we extract the ROI, and then we extract the red channel of that image, ROI image, and then we using the unsupervised algorithm, we try to get the segmented image, which extract the optical disc in this image. Last image you can see the green area, which is the optical disc. We have means, and we then we applying the eclipse over there, eclipse determination algorithm to find the major axis of this eclipse. Similar way, we identify the optical curve using the same approach, and this red area you can see over here. You also identify the major axis of this, and then we divide these two major axis values and find the curve to this ratio, and based on that, means we have to make some decision, means patient has a glaucoma or not, because the CDR is useful to define that things. Based on that CDR value, we find this segmentation, means glaucoma is this image is a glaucoma or not. we have to find that thing. This is one example. Second is I can show the classification of the retinal images, which is give the image as a glaucoma or not. So for that we use this evolution parameters, which is very known parameters. Everyone know about this, I think. So I will not explain this thing. And these are the these parameters which is used like accuracy, sensitivity, specificity, and the F1 score. So in most of the cases, we rely on the F1 score because the most of time in the healthcare, the data is balanced data. We most of the times get the imbalanced data, so we rely on the F1 score. And based on F1 score, we have to measure the performance of the models. So this is the approach. I'm using a small data set like this, 30 images, which I get from one of the doctors from the India. So in this, we have developed these models, which very CNN models, where the models is various deep convolution layers network and various full connected layers, and develop the classifier, and this classifier gives the output like this. The confusion matrix, where the glaucoma images and the accuracy and everything is a result of the training data. This is almost give the equal output because we use the balanced data set over here. And this is so this is one of the application of the medical AI in the medical images. And now I saw my one this is already in the clinical trial. We have developed this software to earlier detection of the breast cancer. So over here we use the ultrasound images of the breast and try to identify the tumor over here. So you can see over here this is a red area which is identify the tumor in this. We developed the standalone software which when you feed the input image like ultrasound of the breast in this software, and that software will be give the output like this tumor along with the all the values of that. And this is the complete analysis that is my input ultrasound image, and after that algorithm we develop the deep learning algorithm over there, which is based on the unit, which gives the output like tumor in this area, which is identifying the green outline, and we generate this diagnosis report where you can see over here, which gives the tumor size, tumor shape, tumor orientation, like echo pattern and the margin, texture, and all the things. And based on that, we give the what is the type of this tumor, because these all the features are used to identify the tumor types in the medical science, and which is we give as this is a simple means malignant type or malignant type cancer we have defined using this all the features well. This is the report we have generated, and right now this software is in clinical trial in the UAE, and we are waiting for this clinical approach of that. So this is from my side. If you anyone have any question, I'm open for that.
Dear participants, if you are having query, then directly now free to ask question, sir.
Meanwhile, the participants are asking the query. I want to ask one thing, Dr. Rohit. At last, you have mentioned that you are deciding the types of a tumor.
Yes, ma'am.
So the tumor type is decided based on which parameter and which are the various type of those tumors.
In the ultrasound, means in the breast cancer, ultrasound, we try to identify the shape and the orientation, then the margin, then the texture of that echo pattern. These are the feature values the doctor are identified based on the image. And then based on that, if my orientation is vertical, then it is a cancer tumor, because there are particular patterns for that.
Okay.
My tumor is in horizontal, means my major axis of tumor is horizontal, then it is the means not cancer tumor. Like there is only a tumor with some water or something like that.
Okay.
So these are the means various values which is they have defined in their means regulation, like they are called as a cancer regulation or the cancer rating, something like that. This is
Okay.
so these all the values are defined by the doctor's booklet. Like we have some like signal processing, like we have the X plus, like there's some theorem, like sampling theorem, like they have defined the tumor. This type of features will be, and this tumor will be this type, like that.
Yes, guys, anyone else would like to ask? I already told during introduction, I was having very vast practical experience also. So having very good exposure of research, not only industry but also because of the business transactions and SAP papers also always around, right? So one can ask the question if it is. I think we are having freedom to unmute, right? Any participant can unmute. If anyone is having trouble to unmute, one can raise question in chat box also.
See, participants have not rights to unmute themselves. Hosts have to make them unmute. So if the participant want to ask, please raise your fingers so host can make them unmute and they can ask a question. Otherwise, they can write in the chat window.
Okay, so I think it seems that on the side of audience there is no any question. So
Yeah.
can we move further?
Yeah, definitely. But I think the next speaker have not joined yet. Just a minute. Let me check.
Probably this time is 6 o'clock. That's right.
So, Rohit, Chirag here. What is the opportunity to have the collaboration with your institute from our IEEE SPS Society Gujarat chapter? Is there any scope?
Right now, sir, I'm working in the startup company. So yeah, we have the people of 10, and I will be asked about this. Means we are looking for the many use cases, like in healthcare. Right now, we have the two project. If you have some ideas and try to make the product or something like that, we can come up with the collaboration. Like we can with our industrial background, means how we scale that thing into industry, means how we bring that thing into the industry level, like the research. And in Europe, means, and sir, in Europe there are lots of regulations. Means in not like India. Means when you go to Europe or something like that in abroad.
Okay.
So there are lots of regulations which maybe come in India in next few years. So right now there so that regulation which help us to make a very good research which can be converted into the product.
Okay.
Means what is I'm saying, sir, right now, most of research are doing, but they are not coming in the market. Means many are so that models and everything are very good, but when we talking about how to scale into the market, means how we use that into the real healthcare system, where this gap is missing.
Okay. Okay. So,
So I also have one query in this point. When you are developing your medical model, the model for the medical diagnosis, are you testing it for the various data set or with once the data set just you are trying and deploying in the market?
Then we have to go for the clinic trial. Means we install that prototype in the clinic and then generate the reports over there.
Okay, then you are And you are validating with the doctors, is it?
Yes, ma'am. Yes, ma'am. Then once that clinical report is accepted by the body, then we can go for the C certification.
Okay, fine.
And once we get the C certification, then we can come with the product. So this is a long way to go to from the development to the product.
Okay, fine.
So this is no one, also not one clinical trial. Means I develop my product in Germany, so I have to test in India. I can have to test in the US or various area of the world. I have to test my algorithm.
But when you are developing your algorithm, at that time, what is your approach? How you are testing your model?
So means we have collaborated with the doctors right now over here. They are one of our research team. They are in our research team. So we consult with them. Their hospital we use take the data and also we test over there. That means MOU made that with that university, means hospital and university. So we provide our product free to them.
Okay.
Hence we develop our product.
For testing.
Yeah, because sometimes, madam, what is happening? Some idea is coming from the doctor side. Like doctor wants to do that. So so in our case, this is the idea. Means two doctors have this idea. So we collaborate with them and develop this product.
Okay, got your point.
Okay, can I ask one question, Rohit sir?
Yes, ma'am.
Sir, actually, you have also given many opportunities in this. So, in that case, if I want to have a mammography case, so can you elaborate some of the idea? Because already we have worked in that mammography, accuracy has been achieved, but you have talked about that product side. So, how any analysis based on CNN or machine learning based approach in which some algorithm has been developed for pre-diagnosis, how to enrich that particular analysis to some product level as a doctor perspective? Yeah.
Yes. So means you do the classification. Am I right?
Yeah, classification and some pre-diagnosis and severity of breast cancer.
So you are in the first stage, like the trial stage, which is called in the healthcare trial stage. Means
Yeah.
so you can develop this one tool like trial system or something like that. It's a product. There's already one product in the market. Which is developing the I forget the company name. They only do that thing. Like they only do the trials. Means every day, doctor means suppose take the means in the any laboratory take the 100 images. The 100 images out of that all images are not having the cancer or something over there. There are many are normal images. But as a doctor, they have to see every images every time. Means every day they have to see 100 images, which is lots of time consuming process.
Okay.
So using this type of trial system, we can reduce the time of the doctors.
Doctor,
Like,
yeah. It's only he can only observe whether some problem is there or some yeah. Probably diagnosis in the positive side means if the cancerous person is there, then only those images will be observed by doctor. And
yes,
other will be discarded by machine itself or the model itself. Yeah.
yes. This is the approach.
Okay. So, any question from participants?
Yeah, I'm also having one question to Dr. Rohit. Sir, you might be using more like computer vision, right? When you
Yes,
develop this. So, in that one, I would like to know that right now which particular model of deep learning is in trending. Like normally is LSTM. LSTM is normally people who like to read, right? For the research. So right now, from your study, what is in the trending?
Sir, means it depends on the application because right now
That's what I'm asking that for medical diagnosis. Like you told that like for CT images.
so your tumor identification most of them use the unit, but in the so in unit what is the problem? The data set, because you require the data set with the ground truth. If there is no ground truth, your model cannot give the perfect output. So you require that type of data set. So there is a two way. Means if you have very good models, then also you require very good data. So if both are equal level, then you get the achievement in the AI development.
I can ultimately, I can say that nowadays in medical domain, there is a scarcity of data set, right?
And sir, also one of the problem is that authenticity of the data. So there also one research right now going on how you provide the authenticate data, also authenticate the model. Means you write that means my model is achieve 98% of accuracy. So so which we have to give which data you use for to achieve that 98 means accuracy, 98%. Yeah, so this is also, and if I'm means also one problem is that if I'm removing your trained model in the deployed system, then your system is collapsed. So how you provide the security to that models? This is also one problem right now.
Now, does anyone has any further doubt? If it is not that, then we will proceed for what of things and then going to present to the respective speaker, right? So, anything now, no queries there. So, Madam, should I proceed?
Yes,
Yes, sir.
sure, sure.
So, Rohit sir, thank you very much to spend your valuable time here. And definitely, you have taken this session from, you can say that, very square itself, right? Everyone will agree with my opinion. This is started from your unsupervised concept, supervised concept. Then you also consider CNN as it is, basic of computer research. Then after you also consider some of the aspects of artificial intelligence, and particularly for healthcare. In that one also, we also discussed about refined image segmentation, which is nowadays the recent need of the community. And finally, we also discussed one of your projects, namely brain tumor. And during questionnaire, we have also discussed your research work. And so this was really very wonderful for all of us. And in future also, IEEE is expecting same type of cooperation from your side. So we have team IEEE, I'm thanking you, and with the same, I would like to present a memento, the team memento to you. So please accept those.
Sure, sir. Thank you, sir.
Sir, is it available with you, sir?
It is opening, sir. Rohit, sir, if possible, can you open your video so that we can also have a group photo?
1 minute, ma'am.
All the participants are also requested if they can just switch on their video mode so that we can have a group photo with Rohit, sir.
Have you given the rights to every participants?
Almost they are getting some opportunity. Yeah.
Yeah. So fine. It's fine.
So who is taking the lead?
I am checking, sir.
Okay.
Your side also, you can also take.
I'm just confirming which suppose somebody is not there, I have to.
Yeah.
But thanks for the cooperation. Right?
Thank you, Rohit, sir. And it would be really nice that if in future if some collaboration or some help is needed,
Sure,
at least
madam.
two, because right now people are working in a software approach very fine. But if we are just helping the medical community in terms of some product, then it would be also a very great achievement from researcher side, so that they can achieve certain benchmark for medical community.
Yes, ma'am, because this is the requirement of the society now.
Yeah.
Okay, so
Thank you, sir.
so once again, thanks a lot for the same. And in future, definitely we will be working together. Not only this our team of hosts, but participants can also join you. And I'm also Right? So behalf of Rohit sir, I can give you a surety.
You are sure, sir. Means you know me, sir. You know me, sir.
Yeah, that's why I'm giving assurance, right? Definitely, anyway. Okay.
Yeah.
Okay. Thank you, Rohit sir. And with the same now, I would like to hand over this session to either Professor Deshpande or Vandana Joshi, as now he is our next session chair. Right? So,
Thank you, sir.
yeah.
Okay, thank you, sir. Before we start, I just
Yes, sir.
want to give some instruction.
Yeah.
Second session will be taken over by Professor Sankar sir. Vanna ma'am will give his profile and everything. All the participants are requested. Our quiz session, which will be every day organized at the end of the third session. Today there is a little modification. We have a quiz after this second session. So all the participants are requested to kindly attend the quiz actively to win some attractive surprises. And feedback form is always generated at the end of the session. So all the participants are also requested to at least give the feedback as the attendance or to avail the certification. So these are the two important announcements. Quiz winner will be announced at the end of the third session. So please be there at the end of the third session. So over to you, Vandana ma'am. Today our second session session chair is Vandana Joshi, Professor Vandana Joshi. She is the department engineering college. So hand over to you, Vandana ma'am.
Yeah. Thank you, ma'am. Welcome to all and the series, talk series rather, of your signal school on multidimensional signal processing. Now today's talk is about the role of AI in healthcare, and I'm just taking the opportunity to welcome our today's speakers, Professor Shankar Parmar sir. Professor Shankar Parmar sir actually has received his MTech degree from the MNIT in 2010, and he is presently working as an assistant professor at Government College of Engineering, Godhra. And his areas of expertise, which includes the biomedical signal processing, healthcare, medical image processing, and the video processing. He has more than 15 years experience in the teaching professions and the 2 years of experience in the industry at IBM and company. He has mentored more than a postgraduate dissertation, more than 10 postgraduate dissertation, and he has reviewed the paper at prestigious IEEE conferences. In the year of 2020, he was then given a innovate to impact I2I, award by the GTU as a Gujarat Technological University Innovation and Startup Center. So, without giving a delay, I just would like to hand over this session to the Professor Shankar Parmar sir. Thank you.
Thank you very much, Vanna madam.
Sir.
Shall we proceed, because we don't want to waste any time for that.
Sure, sir.
Is it visible?
Yes, sir, it is visible.
Yeah.
Yes, sir, it is visible, sir.
Good evening to everyone, and I'm here to have a talk on early detection of dyslexia using EEG. And my name is Shankar Parmar, and I'm from Government Engineering College. So, before I start about dyslexia, might be everyone have heard or everyone have seen that movie from Amit Khan, like Tare Zameen Par. I hope yes, everybody. So in that one, the child was suffering from dyslexia, and important thing about dyslexia is that in our today's scenario, that uh, there these children who are suffering from dyslexia are not intellectually
less, but they are neglected due to this kind of some you can say neurological process or neurological abnormality. So, what is the present scenario of dyslexia in the world? That you can see here. That 30 million in US, 3 million in Canada, 6 million in UK, and 15% in India, according to a survey, are
Shankar sir, is there any network issue at your end? Hello? Hello?
There might be mic problem at the end of Shankar sir.
Okay, okay.
So there is a power cut off at his place. He will join in a few minutes.
The participants are requested, please be there.
yeah.
We will manage.
Hello.
Yes, sir, Shankar sir.
Yeah, actually here there was a power cut issue, so now I have connected to my internet. Now, able to
Yes, sir. Screen is actually about to share, but sir, there is the issue of your voice.
hello, hello.
Yeah,
Now?
yeah. Now voice is coming.
Okay, and the screen is visible.
Sir, screen is also visible.
Okay. So I think I was here only.
Yeah, yeah, yeah.
So we have discussed that these many people in the world are suffering due to dyslexia, and 15% in India are also suffering from dyslexia. And the main important thing about this is many of them don't know that they are suffering from India, from dyslexia. So that is the biggest challenge in our society. So these are the motivation which motivated me to work in this field. That like approximately 15% of world population suffering from this. In India, also statistics depicts around 15%. Many of them don't know that they are suffering from dyslexia, and this article was published in Times of India, dated January 31. So, very less research work also has been done in uh, from engineering point of view. Might be they are working from medical point of view, but from engineering point of view, very less work, research work has been done. So, what is the status in Gujarat? So, you can say that uh, health and education department, they are also taking initiative to train teachers, special educators to work in this field. Primary school students are also to pick up the early signs of such disorders. So in my talk, the important word early suggestions at an early age means while they are entering into the school, or they are in first or second standard. That was the aim of, that is the main aim of this research, that at an early age. And some training sessions are also have been organized by Gujarat government, and they are also taking initiative. But important thing is they are trying to educate, uh, you can say, teachers instead of focusing on students. So our aim is to focus on students and detect dyslexia at an early age, so that a remedy can be done at an early age and a great intellectual can be saved. That is the main motto of our research. Might be you are having that, it will have writing problem, it will have spelling problem, it will have text reading problems. But under the problems in reading single word, reading non-words. Non-words means they cannot differentiate between the proper word and having meaningless words. So that is the nonsense words. And language processing problem, like speech sound processing, they are having problem in phonics. Means they cannot understand the words properly, F or E or B. They are having confusions in these words. So what are the standard tests right now? They are Woodcock Johnson test, Bachelor Individual Achievement test. These are the standard psychological tests which are being performed to identify dyslexia. But important thing in our country is that once this kind of neurological problem occurs, doctor suggested to neurologist. That time our parents thinks that no, my children is not mad or something like that. So why should I go to neurologist, or why should I go to psychologist? My child is not mad, and that is the biggest trouble. So to remove that, what we can do, we can have a kind of screening test using this kind of whatever we are suggesting, and from that we can screen or filter out those students who are having signs of dyslexia, and later on they can be have a remedy for that. So the skills which are testing dyslexia are like phonological awareness, decoding means ability to decode words quickly and accurately, reading fluency accurately and fluently. A child can read aloud a paragraph or not. Rapid naming, quickly name letters, numbers, objects, or colors on a page. Are they doing this? That is the main important thing. Based on this kind of tests or skills, we can assess whether he is having dyslexia or not. Now, so up till now, whatever we have discussed is related to what are the traditional techniques or traditional testing. Now we are moving into the our domain, that is engineering domain. That is now being an engineer, we can have a automatic kind of thing, or we can have a technical solution for that. And for that, as it is related to neurons, so what we have planned that we can detect it at an early age using EEG, which is electroencephalogram. Now, what is electroencephalogram? That is the measures. It measures the activity of large number of neurons. It is non-invasive, painless, relatively low cost, and electrodes, which are measuring the voltage differences at the scalp in the microvolt range. And the voltage traces are recorded with millisecond resolution, which is a great advantage over brain imaging. Like, why are you not going for MRI or PET? Why? Because of this reason. So you can imagine here that one electrode is placed over here, and say here another electrode, and this is your reference electrode. So the voltage difference will be captured over here. It will be amplified, and this kind of waveforms will be visible to you. So, what are different states of our mind? Like if you are excited, if you are relaxed, if you are drowsy, if you are deep sleep or coma, different patterns will occur. And this is our motivation also, that for different stage of mind, different pattern is occurring, and that will give us kind of stimulus that we should work in this domain, and might be EEG will be helpful in detecting this. So based on this, researchers have identified some brain rhythms which are very common, which everyone should know if you are working in EEG domain. So these are 5 major brain waves which are distinguished by different frequency ranges: alpha, theta, beta, delta, and gamma. importantly gamma, which is 30, which is having frequency range between 30 to 200 hertz, which is a very having a spikes like this. So this will occur generally in learning, problem solving tasks, cognitive processing, beta wave, which will occur in whenever you are awake and alert, conscious thinking, excitement. When alpha wave occurs when physically and mentally relaxed. Theta wave occurs whenever you are having creativity, insight, deep states, dreams, deep meditation, and delta, which is whenever generally you are having sleeping time. Now, as I have discussed that it is an EEG, so what is an electrode placement? And generally, whenever you will refer, it will have 1020 international standard which they are following. So what is this 1020 international standard? Here you can see this. So this point is called your nasal, and this is called your enian. These are your two preauricular points. So if you will draw a line from here to here, so this is supposed to total 100%. Of out of this 100%, 10% will be marked over here. Of that, 20% will be marked over here, then 20%, then 20%, then 20%, and finally again one mark will be at 10%. So this is how the electrodes will be placed. Then that is why the name is given 1020 international standard. So, if you will purchase any electrode, any EEG cap, it will follow this kind of standards. So generally, you will have like this. This is one center line. This is another center line. So this CZ will be your center one, and this is like parietal. So F stands for front. This is parietal. This is O means occipital. Based on the regions of the brain, the names are given. And if you observe here, this electrode will have even number, and this will have odd numbers. From that, you can identify different things. Now, EEG will be captured while performing various tasks. That is very, very important. Like, what are the different tasks generally which are being observed? These are auditory oddball tasks, MBAC tasks, spatial MBAC tasks. So, what is auditory oddball task? It is something like used to evoke potential. What is it? Suppose here a standard voice will be heard. Okay, you can hear, you can see this. You can see this figure in which they will listen or they will see the standard stimulus. In between, rarely a randomly, you can say rarely and randomly a you can say target stimulus or that kind of thing will occur. Once this target stimulus will occur after 300 milliseconds in normal people, wave will occur in the brain. That will be captured by EEG. So that is called P300 wave after 300 milliseconds. So that this kind of task is also being offered by psychologists to identify whether the person is normal or abnormal. Not saying about right now, not saying about dyslexic, but generally it has been observed. So once this kind of standard task will come, the patient will have to press one number, and whenever this kind of target task will come, they have to press another number or another button. By that way, we can identify that he is correctly identifying the things or not. So this is called oddball. Why? Because this thing is coming very rarely. Okay. So you can hear that this is 0.5 kilohertz signal, 0.5 kilohertz signal, which is standard one, and in between randomly 1 kilohertz signal will occur. At that time, they have to do something, and after 300 milliseconds, a wave will get generated. So if this is not getting generated, that is also an alarm that might be the children is having some problem. MBAC task, which is generally being used for identification of dyslexia. Why? Because you can see here what is MBAC task. See here, first H will be shown, X will be shown, D will be shown, M will be shown periodically on the screen. Now zero back is the letter and X means whenever the X will occur, person will have to press the button. Otherwise, don't. Whenever the X will occur. Now, one back task that is also including memory as well. Like, see here, you can see H, G, D. Again, D is repeated. So, at that time only you have to press the button. Otherwise, not. Like, see X here, then V, then again V. Then only he has to press the button. Here, whenever X occurs, whenever V occurs, whenever N occurs, two back pins in both H, M, P, then M, one letter before. So this kind of tests are also prescribed. Only is to here in one back as we have seen, if the square occurs at the same position in the next string, then only he has to press the button, and after that means during that time we will capture the EEG. That will be called evoked potential. Evoked. So primarily one of the paper was published in IEEE Recent 10 Humanitarian Technology Conference. The name was Performance Evaluation of SVM with Non-Linear Kernels for E&TC. So the primary flow of this, like here we will have input, then we will have pre-processing, then we will have feature selection, then we will have channel grouping. I will discuss about feature selection as well in detail at the end. In classification, and again I will discuss about validation, which is not the part of this paper, but as an extension of this research, we will discuss about that also. So raw EEG, as I told you, these many students from Germany, from France, Germany, and Finland. And this is what I will suggest, that this is the largest data set of this study. We have not come across any study which would have considered more than 391 students in this kind of research. What kind of stimulus they have used? That is a passive waterfall paradigm that they have used. There were 391 participants. They have images. They have tested for speech stimulus as well as non-speech stimulus. Now, I hope that everyone will be aware of what it is like. What kind of thing which will give a waterfall paradigm. So, it is a standard type of stimulus. Many rows. So we took almost 2 to 3 days to arrange in a correct manner so it can be processed further. Data set. So pre-processing can be done. It will use the EEG. I will request you. Is it audible? Hello.
Your voice is not suddenly coming.
Yes.
Might be an internet issue, speed issue at your end, I think.
Yeah, 1 minute. I'll go outside. Yeah. Might be now you will not have the issue of voice.
Now it's clear. Yes. It would be good if you start again from the end back analysis, after end back analysis. Till that we
Okay,
got your
back.
yeah.
Okay, and back.
And
Yeah.
back, yeah.
Here, Here.
Yeah, but yeah.
So, and like we saw that in zero back means a person has to recognize a particular word, a particular letter only. See, I told you that if he has to recall X only. So whenever the X occurs on a screen, he has to press something. Otherwise, not. While in one back, what he has to recall that what was the earlier. So it will check its memory as well. H, G, then D, and again D is repeating. So at that time only he has to press. Here X, V, then V. Again V is occurring at that time only he has to press. Two back means two letters back. So it will check memory more. But generally one back task is being preferred for identity for easy recording. Partial and back, it will have shapes instead of letters. So here in zero back, if whether the square is occurring at this place or not, and only he has to see this. While in one back, if the square is occurring at the same place, then only he has to press the button, otherwise not. And at that time, the EG will be recorded. And this is our research paper which was published in 2021, performance evaluation of SVM with non-linear kernels for EG-based dyslexia detection. I hope everybody will be able to hear these things.
Yes, yes.
Okay, so generally this was our flow of the research. Here from input, then pre-processing stage, then feature extraction, then we will have feature selection, channel grouping. Channel grouping we have done, and feature selection I will discuss in detail later on in this talk. Classification, we have used SVM. Cross validation as well. Cross validation, other techniques also I will discuss in later on in this stage, in this talk. So raw EG data, we have obtained data set from the authors of this paper on a request base. There were 391 students who participated in this research and from different countries. And this was the statistics of the participants which was provided. Stimulus which was used was a cross-linguistic passive audible paradigm. Now, something about data sets. So there were 391 participants. There were 3 languages. The stimulus which was given was speech or non-speech. Non-speech means some tones were created instead of a speech like why. Instead of that, tones were created. So you have to identify those tones. Standard or deviant type. 21 electrodes were there and 300 samples for each electrode. So this many rows were there in this data set. So it took us 3 to 4 days to rearrange them in a manner so that it can be useful for further analysis. Pre-processing, it was done using EEG lab. I would like to request everybody, those who want to work or those who wish to work in this field, EEG lab, which is a plugin from MATLAB for MATLAB, not from MATLAB, for MATLAB, EEG lab, which is something like GUI, so you can use those predefined GUIs and you can perform pre-processing very easily using this one. Not filter back.
Excuse me, again your voice is breaking.
Hello.
Yes, now it's audible.
Actually, our college is in interior area. We have to also move.
I
Get
understand this problem.
statistical features up to this point it was audible. Can I start with this only or?
Yes. From this point.
Okay, so statistical features, these are the features which were extracted, mean, standard deviation, and all those things. Energy which was extracted for different bands like delta, theta, alpha, beta, which I have discussed earlier. So to extract these bands, you have to either use band pass filters or some wavelet based filters are also available. You can use either one, but first of all, you have to extract this kind of bands, and for each band, the energy will be calculated. Spectral features, you can see from this figure that what is the peak frequency. So first of all, for that you have to plot power spectral density versus frequency. So you get that, and for this also different commands were there in MATLAB. So you have to use a suitable PSD command, and after that you can extract these features. So you can see here that it is occurring at this point. So that's why peak frequency is 25 hertz, amplitude, width, area. You can extract this kind of different features, which can be different for different persons. EEG descriptors, these are very useful for EEG processing. He has published paper in I think 1970. Still, they are very features are very popular. Basically, these three features are there: activity, mobility, and complexity were there. Activity is nothing but variance sigma square x. Once you obtain sigma square x, mobility, which is mx, which is sigma x dash by sigma x. Now, how will you get sigma x dash? Using the first derivative. Complexity, using the second derivative, and these are the equations which are used to identify activity, mobility, complexity, fractal dimension. This is also an important concept where you can see that n equal to m raised to d. Now I'll explain that this is magnification factor and self-similarity dimension. So from here, if you want to get d, so you have to use this kind of equation. You can easily understand this by taking log. So now if this is an original object, a line, which is divided into three pieces, so magnification factor is 3. If you will use this, dimension will be 1. You can see a line is a dimension having 1. Square magnification factor is equal to 9. So now 3 raised to 2. From here you will get dimension. Cube dimension. Hello. 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 Hello.
Yes, sir.
Now it is there.
Hello. Hello. Hello.
Now it is there.
Okay. So I think fractal dimension I have covered. Any trouble in this? Hello.
No.
Okay. So important one, which is cat's fractal dimension, which is also being used in EEG waveforms, and the equation is d equal to log n divided by this. So d equal to planar of the. If somebody wants to know in detail, I'll explain him or her later on. He or she can contact me. Important thing is, in this paper they have discussed that for awake and alert, for drowsy, for light sleep, for deep sleep, D is occurring differently in a different range. So that was an investigation of practical dimension, and that's why we have selected this as a feature. So you can see here D differs for each state. Up to this point, any problem? I think so. In audio. Hello.
No, you can
Okay.
continue.
So in the earlier flow, whatever I have shown, that first of all we'll have raw data, then pre-processing, then feature extraction, and after that I have told you that about channel grouping. Now, what is the importance of channel grouping? That we are having 21 electrodes. Out of 21 electrodes, if we can do this with very less number of channels, that is also an achievement. So we have tried that also, channel grouping. And now how you can achieve it based on this? Like we all know that left brain function is responsible for this kind of activities. Right brain function, right brain is responsible for this kind of activities. So first of all, we have divided in like what are the channels which are from left hemisphere, what are the channels from right hemisphere. Then also, see, these are the channels from right hemisphere, left hemisphere. Then we have tried for this also lobes, like frontal lobe, central, then parietal lobe, occipital lobe, occipital, pre-occipital, temporal lobe. Why? Because each lobe is also responsible for different activity. So we have also tried to club them according to their. So this was the channel grouping which was performed by us, and based on this, classification was done. Like, so what you can see here, first of all, for all channels, all features are extracted. Then grouping has been done, and only for those electrodes, features were extracted, and then classification was applied. Now, classification generally we have used SVM because from research papers only we came to know that SVM is the most powerful classifier for this kind of data. So, and we have used non-linear SVMs. Why? Because generally, what is SVM? That it will try to create a hyperplane to differentiate data or to differentiate between two categories. So, if the data set is too hard, like this kind of thing, then linear kernel will not be able to partition them. So you have to go for a non-linear kernel like this. See, here a square. Instead of that, if you can convert this data into this kind of dimension, and then this kind of hyperplane, which will be a linear one, that can differentiate between those 2 points. So we have used actually polynomial kernel, Gaussian kernel, sigmoid kernel, and these are the equations to implement those kernels. And we have chosen p equal to 3. Then in this one, sigma equal to 1 by root 2 and k equal to 0.1 and delta equal to -0.1. This has been chosen from a research paper, not by hook and crook. Then cross validation has been applied. Now, what is cross validation? Might be some of you are aware that suppose you are having 100 persons data set, and generally you are having like you will keep 70% for training, 30% for testing, and something like that. So, which 70% you will select? It may happen that if you select a 70%, it will not have a dyslexic person's data set, and in 30%, 30 you will not have others data set. Are you able to hear? Hello? Hello?
Yes.
Hello?
Yes,
Yeah.
Yes, sir.
So, what happens in cross validation that 100 people's data set will be divided, suppose, in 5 groups, 20 persons, one group, another 20, another group, another 20, another group, like this. Now, at a time, suppose one group will be given for testing and the rest of the 4 will be given for training. So 80 will go for training and another 20 will go for testing. So that is how you will have 100. Now next time, the person, the group which was there in testing, it will come in training, and another group will go for testing. This is how you will have 5 times you will have accuracy, and out of all these 5 times, whatever will be the average considered for as the final result. So this is how cross validation has been performed, and these were our results, which were published. We were able to achieve 62.4% accuracy with all channels, and with left hemisphere it was 60.1. That also suggests that left hemisphere will be, if you will target the channels of left hemispheres more, might be you will achieve better accuracy. This was the results with speech stimulus. Earlier one was non-speech stimulus. This is with speech stimulus. Okay, so this was our paper. Now I will go into the details of feature selection. So what is feature selection? That is, like as we have discussed earlier in this talk, that different spectral features, different time domain features, different fractal features. It consists so many features. Now it may happen that some of the features will not constitute importance as like other features. So we have to select particular features only instead of moving for the whole feature set. So how do you select it? Because that is also an important one. So feature selection, you can see that thousands to billions of low-level features. So you can have all these features. Out of that, might be some useless features are also there, some redundant features are also there. So you have to achieve this bullseye. And for this, different methods which are available: univariate method, multivariate method, filter method, wrapper method. Generally, this kind of filter method, which will ranks features or feature subsets independently of the predictor, which is being used. Now, what is rank? It will many this one. So what happens is uh, feature extraction features for feature selection, and you are expecting that from 1000 I should come up to 100. So it will give you a ranking kind of thing, that this feature is having more importance, this feature is having more importance, this feature is having more important. So from that ranking, you have to decide a threshold, and you will reach at a point that okay, these 100 features are very important. So those 100 features, now you can imagine that instead of having 1000 features, you will now come up with 100 features only. So those features will be applied to a classifier block, and finally you will have so that will reduce time, that will reduce complexity a lot. That's why this has been considered a powerful tool. Types of feature selection. So feature selection is also a very important block in this research flow. Now cross validation. I told you that cross validation also, it is very important. So what are the different cross validation techniques which are available? So first one is hold out cross validation. Now, every time it will randomly select 70 out of that and 30. Another time it will get of that and 30 for testing. Another time it will randomly select 70 and for validation of 30. We hold result of every bias. they have divided it into three parts. And this will go to the
Sankar, there is an issue in your voice. Hello.
Okay. I again come. Hello. Hello.
Not clear yet, not clear. Hello. Yet not clear, Sankar.
Hello. Hello. Hello.
Yes, now it's clear.
Now it is clear.
I think I was at fold crop validation. Hello.
This
Hello.
part is remaining Jaipur validation that slide was there.
Yeah, and this simulation, this kind of GIF was running. Hello.
GIF we cannot visualize. Now it is coming.
Yeah, yeah. So you can see here that there were 12 participants. They are divided in 4 parts. The first time this will go to the test, next to train. The next time this 4 will go to the test, another in train. This is how everyone will go to the training and testing. Everybody getting it? Hello?
Yes, sir.
Yes, sir.
Yeah. So another version of k-fold cross validation is stratified k-fold cross validation, and in our research we are using this only. What is stratified means? So as I told you that first of all randomly it will get divided in 3 parts as earlier one. But while choosing this randomness, one thing will be kept into the mind that number of you can say dyslexic person here in our case, they will be almost same in each fold. You can say each randomly divided part like this. See here, out of this four, suppose one is having dyslexia. So here in this also one will be having dyslexia. Here also one will be having dyslexia. So it will not happen that one complete fold will not have any person which is having abnormality. That is stratified k-fold cross validation, and I would suggest that everyone should use this stratified k-fold cross validation. So data is partitioned into k-fold such that the validation data has an equal number of instances of target class label. And then repeated k-fold cross validation. Now, this is also trending nowadays that once you have done this kind of thing, like I repeat again to give a more clear idea that suppose you are having 100 people, that you will divide in 5 parts, 5 groups randomly. Then first time you will go for testing, another 4 will go to the training and that kind of thing. So you got 5 different accuracies. Next time again you will apply folding. So again they will get divided into 5 parts randomly. So it may happen that first time whatever folding you folds where you were having, next time you will not have another same folds, and again test your model with it. So again you will have 5 different accuracies. So that is called repeated K fold, and every accuracy will be averaged, and finally that will be declared as your model's accuracy. So performance via K fold cross validation can be noisy. Why? Because you are dividing in randomly. So you are doing it repeatedly. And finally leave one out cross validation, LOOV. So in that one, suppose out of 100, 99 will go to the training and only one will go to testing. Next time, second one will go to the testing, remaining 99 will go to the training. Third will go to the testing, remaining 99 will go to training. So you will have now 100 times accuracies. So the disadvantage of this one is it will have more biasing and variance as well. But if your data set is small, then some researchers are employing this technique also for cross validation. So you can see here this. There are 8 participants. So at a time only one is going to testing, remaining for training. One is testing, remaining for training. Okay. But now at this point, I would like to give you one clear idea that first of all, we are having raw data. Now it will go to the feature extraction block. Then directly don't apply it to the feature selection. So here feature selection, and directly don't apply it to the classifier. Don't. You cannot go like this. Otherwise, it will have a biasing. So what you have to do here after feature extraction, you have to do folding. After feature extraction, you have to do folding. Those who are in a training set, for them only you apply feature selection. I repeat, for those who are in a training set, training folds, only on those folds you apply feature selection, and those features only will be extracted from test fold, and that will be finally go for classification. Generally, what people are doing after feature extraction, the whole set is going for feature selection, and they will be tested for, and they are claiming accuracy 95%, 100% also, 98%, 99%, but that will be wrong because it will introduce bias from this stage. So if you are appearing for a reputed journal or reputed conference, might be your research will get rejected due to this error. So please don't do this. So what are the challenges in our research right now we are facing? That is creation of our indigenous data set. Like we have obtained data set from other researchers from other countries, but in this one, language processing. So language, once the language changes, the challenges will be there. So we need to create a data set for our Gujarati students. Task selection is also a challenge. Why? Because which task you will prescribe, which will clearly identify dyslexic student, that is also a challenge. Channel grouping, as I told you, that it is also a challenge, that if you can reduce number of channels, that is also a very important one. Cross validation, that is also a challenge. Why? Because how you will perform cross validation, that is also to authenticate your model. Otherwise, if you want to do it very traditionally very simply like this, then also not a problem. But if you want to authenticate that in each and every condition, worst condition also your is challenge. So this is from my thank you. Oh,
Chandra, again, there is an issue from your end.
I think you have covered all of your points, right? And time is also about to complete. So on behalf of Shankar sir, I request participants, if you have any query, just drop your query in the chat. And Vanna madam, you can now continue the session.
Yeah, thank you, sir. Thank you, ma'am. So I hope we should attend some query first, right? So we will wait for 2 minutes for if any query is there. Yeah. I want to ask one query actually. Sir, as you have given one spectral analysis for the EEG, right? That as one of the features we can use. Am I audible?
Yes.
Yes, you are audible.
Yeah, okay. So, is it any criteria like how we can identify that which wave has a highest wave and which is the slowest wave as in terms of we are saying like if the alpha waves is get highest as compared to the theta wave. So, how we can define the threshold of your high value of the alpha wave or high value of the theta wave?
hello, yeah. Now hello.
Okay, my question. May I repeat my question?
Yeah.
Yeah. My question was like how we can define the threshold for defining the high peak value of particular frequency.
What defining high peak means?
Yeah, peak
Okay.
value for the frequency like that is if we are saying that if I have a highest alpha wave, right, compared to the theta wave, so how we can define that high value for the alpha wave? How we can compare with the other ones?
Okay. No. Actually, what you do, as I told you, that you have to extract each band differently, and then for each band you have to identify peak value, high value, and so for each band you will have all those features. So you
Okay,
don't.
but that peak value will be different from the different patient, right?
Yes, correct. Yes, that will be used as a feature.
Yeah, but if I want to compare with the standard peak values, may I get such a kind of the things?
Actually, in this case, there is no standard peak values.
Okay, in
There
any
is,
case, there is no case.
yeah, in means you are having a range that for normal people this is the range. So if it is not coming in this range, that will be considered as abnormal.
Okay.
You are clear.
Okay. Thank you, sir. Anybody has any other question?
My question to Sankar sir. Sir, you have mentioned certain challenges at the end of the slide. So
Yeah.
there is one challenge that you have mentioned, that is channel grouping.
Yeah.
So can you elaborate actually what is that particular aspect and how it is important to deal with this kind of disease?
Yeah, actually, channel grouping, whenever I have discussed at that point in my slide, my voice was breaking. Channel grouping, why it is important? Because if you will group the channels, means if you are able to perform the same task with less number of electrodes, channel means electrode, I mean. So that is how you can reduce the complexity and accuracy also can be improved. But what is the challenge here? That which electrodes you will target? That is the challenge. That with 21 electrodes, if you are getting suppose 70% accuracy, but if you are you able to do it with only 5 electrodes, which are very important? Hello?
Okay, so you have
Yeah.
to recognize important electrodes who are
Yeah.
only responsible to at least make the decision
Correct.
of the disease. Okay.
Like the feature selection, instead of that, here it is electrode selection.
Electrode selection. Okay, and the electrodes are actually considered as a channel to
Yeah.
which we are getting some signal, and those channel grouping will be make the decision of severity or
Yeah.
okay.
Correct. Means like I told you that if you select only channels of left hemisphere only, so out of 21, if you are going for only 10 electrodes, which are pertaining to left hemisphere only, and are you able to achieve more accuracy or the same accuracy, then also it is an achievement. Why? Because you are doing it with very less number of data.
Okay, got it. Thank you. Is there any query from participant? Okay, Vandana ma'am, you may proceed with our.
Okay. Yeah. Okay. Sankar sir, we are very grateful that you are accepting our invitations and just for giving your excellent knowledge about the EG. Right. So it was a very informative session as we are getting some sort of knowledge about the ML as a cross validation and the EG. So it is a combination of a biomedical with the ML. And I'm sure it is pretty sure like as that this is knowledge we are giving as you are given that it will be definitely helpful as in the research. So yeah, as a token of love or appreciation, I just would like to offer the one E moment actually. So kindly accept it.
Thank you very much.
Yeah. Is it visible? I think, right?
Yeah, it's visible to me as list.
Yeah. Okay. Yeah. Thank you, sir.
Thank you very much. I will not be able to start my video because nothing will be.
Okay. Due to the power cutoff.
Yeah.
Okay. So first of all, let me thank you on behalf of our entire team that at very short notice, just in afternoon, we have just invited our speaker to just deliver his expert knowledge in this field, and he has accepted our knowledge and deliver a very good technical talk. And many of the researchers who are present in this session, they are also working, so they have been also have an idea. And one more thing that I would like to appreciate about Sankar sir, that the way of presentation, the slides that he had portrayed, it is also really meaningful and very attractive to just convince the concept of technical talks. So it is also really appreciable. Thank you very much, sir, for your kind knowledge and sharing your work with our researchers. There is an important announcement that quiz will be there for the participant. It will be before third session ending. It is right now hosted and it will be lasting till 7:30. So all the participants are requested to please proceed for the quiz. Meanwhile, already our third speaker, Dr. Ashwini ma'am, is already there. So we welcome you, ma'am. And we have our session chair Rakesh sir from GSET. Welcome you, ma'am.
Thank you, ma'am. Thank you.
Good evening, Dr. Ashwini.
Good evening, ma'am. Good evening, sir.
Good evening, madam.
Rakesh sir is there from GSET.
I think he has not joined yet.
Okay. Just we wait for 1 minute more. If he will join, then we will start. Otherwise, we will proceed further. Just wait for 1 minute.
So, clicking, madam?
Yeah, I will start.
Yeah, we should
Okay.
start.
Uh,
Yeah.
Welcome you, ma'am, for our last session of seasonal school. So, before proceeding further with your technical talk, I would like to give some brief briefing about your profile. So, I would like to just introduce our speaker. Dr. Ashwini Deshpande is an associate professor in Electronic and Telecommunication Department at Cummins College of Engineering for Women at Pune, Maharashtra. She has published more than 30 plus research papers in referred national, international journals and conferences. Also, she has registered 2 Indian patents. She has completed a funded research project under the Joint Research Program by Indian Space Research Organization at Savitribai Phule Pune University, ISRO Space Technology Cell in the year of 2018 to 20. She has also completed 2 industrial consultancy projects in the area of signal processing and video processing. She is working as a reviewer for a referred journal of Elsewhere IIT IEEE Transaction. She has also received an Outstanding Woman Award for Research Project of the Year from Ganesh Singh of Educational Impression, Roorkee in 2021, and Outstanding Woman in Engineering area in Electronics by Winners International Women Awards in March 2020. So list is endless, and without wasting much of the time, we should actually start with our technical session. So welcome you, ma'am.
Thank you. Yeah, thank you, ma'am. Thank you for the introduction. And before starting, I extend my thank you to Dr. Meeta ma'am for giving this opportunity and considering entire organizing team, and yes, Dr. Chirag sir. So, ma'am, shall I start my presentation?
Sure, sure.
Yes, yes.
I'll share my screen. So, hope the screen is visible.
Yes, it's visible, madam. You can continue.
Yes, thank you, ma'am. Thank you for confirming. So, this being the last session, I hope that participants are not in the mood of ending it. I mean, when will it be ending it or ending it sooner? So, the title of my presentation is the recent tools for practical signal processing and analysis. Having seen the different titles in this seasonal schools, say the talks basically. So I'd seen that there are many, say, the fundamental to the advanced concepts being covered, and considering them as the background, I would like to have not only an introduction to some of the recent tools for handling that signals and doing some analysis, but also demonstrating some of them. So the agenda here is, say, to take a look at, just take a walkthrough for what are the signal processing operations, what is the workflow basically, then what are the different tools which are primarily being used for the practical signal processing. And then in the end, I would like to demonstrate some of those signal processing tools in order to perform its analysis. So signal processing, as you all know, that it's an essential, I would say, a tool or signal processing that comprises of techniques and a set of algorithms. And in itself, it is being used in the variety of applications, not only from the research perspective, but yes, in the industrial applications as well. So the signal processing, it basically does the transformation of the data for a sake wherewith just by the direct visualization or an observation or just a collection of the data cannot tell us so. So that transformation, once being done by the signal processing techniques, that is more legitimate for understanding by the say the users, by the researchers. So the signal processing, it consists of different pre-processing steps onto the real life signals, then perform the measurements, comparing different signals, analyzing the signals, transformation of the signals, and so on. And the signal processing, it basically allows to us as an engineers and scientists to perform the analysis, do the correction over the signals, and only the so these are, I would say, some list of applications of the signal processing where we find that it has been extensively used. You see, data acquisition is there and we do signal processing. Audio part is there, we capture the audio and it is being intended to perform some compression. Speech is there as a signal. It is being widely used for the biometric applications, and we perform processing. Digital images, graphics is there, and we perform processing for extracting the info from it. Then the video signal is there, and there are a lot of say modalities of the applications of the video signal. Then there are other set of signals which are practically the location domain, as in the radar, sonar, lidar, and for all those signals, we perform one or the other type of the signal processing alongside the optimization as well. Then we do see the seismic signals, geophysical signals, say some even the economic models, the economic modeling that is extensively making use of the signal processing application. So again, this list is kind of endless. These are some of the applications. What I would just have summarized into one slide to give a glimpse that yeah, in all these walks of the domain, the signal processing is extensively being used. Now, in the signal processing in general, the workflow goes as either we have the say the loaded or say the saved form of the data, which can be the 1D, 2D image, time series video, or we are capturing it in real time. And in all these formats of the data, we apply some form of the pre-processing in order to do a more exploration about that signal. And post doing that, we perform the feature extraction. And then hereafter, we apply the ML and DL techniques to say to have the more applications out of the signal processing steps. The signal basically we express in primarily three different domains. That is signal either in time domain, signal either in frequency domain, and signal in spatio-temporal domain. So these are the different ways in which we express the signals. The signal processing operation, once we express that signal into one of the domains, the different signal processing operations that we conduct, it can be smoothing, denoising, degendering, then outlier removal, can be simply waveform generation, like say the music synthesizer, I would say. Then it can be a simple signal analysis where the fundamental operation is convolution operation. Correlation types as in correlation of auto or the cross correlation we do perform. Sometimes even the peak finding works for a very simple application like say R2R peak finding. Then apart from the signal in time domain analysis, we also do the transform domain operations, where with the fundamental transformation that we apply is the Fourier transform. So it can be for the 1D signal, it can be for 2D signals. And there are again the list of transforms actually, like the short time Fourier transform, wave relates, or even the custom domain we do work. Then there comes the system analysis with spectrographic or the spectrogram-based representation or the periodogram-based representation. So in most of the cases where the signals have the non-stationary one, so much of the information we could extract through this spectrum analysis, which is where the spectrum basically is in the form of the spectrogram or the periodogram. Then another very important, I would say, the functionality in the signal processing is about the filtering. So there are digital filters, which are with the constant coefficient filters and the adaptive filters. So having known these fundamental operations within the signal processing, and then alongside having the data, signal is a data basically. So that data in the form of, sorry, shall I continue?
Yes, you can.
Yeah. So having the data in the form of say a text, image, audio, video, can be databases, some identity files, some Excel sheets. So we are applying one or the another signal processing operation for the further processing of it. Now, with this background, what is the role of signal processing tool? First of all, in order to conduct, in order to carry in any one of these operations, may be a simple convolution operation. When we say we are in the signal processing and that to a digital signal processing domain, it is necessary that we should write a code and we should write a function, and then thereby that said signal processing operation will get implemented. But for sake of fast prototyping, in place of starting with a starting point as writing a code, if we make use of an interactive tools, they help us to better visualize, process, and analyze the signal in one of one of these domains, as in the time frequency or the time frequency domain. So most importantly, the signal processing tool, it helps reducing the coding efforts of the scientists, of the researchers, and of the engineers basically. So it helps speeding up the prototyping and also doing some say the real life simulation of the scenarios of the environment where the particular application will be ported or deployed. Now, this is a list of some of the signal processing tools. Widely known to everyone, the most popular one is the MATLAB. Then, apart from that, there is a LabVIEW, there is a Mapple's signal processing tools by Maplesoft. There are some open source software which are analogous to the MATLAB, like Octave is there, Scilab is there. Then in the Python framework, we have SciPy. Then there is data acquisition software also, which extensively supports the signal processing the operations basically given by the Microsoft. Then there is also interesting, say, Origin Lab. Here is the website. If time permits, in the end, I would like to also take a walkthrough for this website also, where you will find that there are apps actually which are being provided, and via the apps we can do a simple to complex type of the signal processing task. Then there are signal processing tools supported by the consortium of the ECG imaging CEI, and in particular for the medical, say the signals, particularly the ECG based signal. So they have provided lot many signal processing tools. So out of all, basically the agenda over here right now is to take a look at how some of the interesting MATLAB's app basically they work on one of the signal of interest. What I have considered here is an ECG signal. So in particular, I would like to take you through the demonstration of the signal analyzer app, signal multi-resolution analyzer, and the signal labeler app. After that, we'll have one more demonstration where I would like to show you how starting from capturing of the real-time signal and end-to-end signal processing and the machine learning model deployment can take place through one of the interesting tools, that is the Impulse H tool. So the signal analyzer app, basically, this is a glimpse of it, where this is providing us all the support for pre-processing the fundamental signal, then doing its time-based or the spectrum-based analysis, most importantly, without writing any code. Instead, it will generate a code for you, it will return a script for you once you perform various steps of operation. We'll look into this part. Then, multi-resolution app is another interactive tool where you can have the visualization of how exactly the wavelet is going to operate in terms of decomposing the signal and also reconstructing the signal by having the selected levels of the decomposition. Then the signal labeler app, which is a very important, I would say, a step when we start with the machine learning based application, and typically the supervised type of the machine learning. So even in the industries, this kind of the labeling task is extensively being done, or I would say explicitly is being done when there are some real life or the real time data sets over there. So how exactly the labeler works for the ECG signal, that will go through, that will take a look at. Now, since in my demonstration, I'm considering the ECG signal as as one of the say the fundamental biological signal. So a bit of know-how, of course. I understand that up till the previous session, you have had a very advanced knowledge about the ECG signal, its processing, and so on. And wherewith here, I'm just taking a very fundamental, but the way the signal can be tackled via the tool. So from that perspective, one more times, here is how the ECG signal looks like, and there are two waveforms in particular in this template, that is the P wave, T wave, and the QRS complex. And most frequently occurring sources of noise that we have to deal with are the power line interference, baseline handling, and the muscle noise interference. So with this background, now I'm just switching the screen and going to MATLAB. Hope the screen is visible. Yeah. So now, in the demonstration part, basically, as I mentioned, that I have considered ECG as a signal. The first and the foremost thing being done here is to handle the ECG data. We should have the signal available with us. PhysioNet is one of the very popular data sets from PhysioNet ATM. You can download that. Here with I have considered this ECG database from the MathWorks site itself. And if you take a look at here with, in all it contains 210 math files. So out of this 210 math files, here with in the demonstration part, I've considered just a single file. Now, the known parameters here are all the signals. They are sampled at a rate of 250 Hertz. And these are the region labels as mentioned earlier, P wave, T wave, and the QRS complex. Now originally this signal is having a length of, just executing this part, and it comprises of nearly, give me a moment. Sorry, because there is a bit of overlap between the screen and the MATLAB this thing. Okay. So if you could take a look at that, this original, just come to the profiling, the original signal, it comprises of the total samples, that is 2,25,000. Out of all, here I've considered only 15,000 samples for the further analysis. So once again, I'll run this part. And here comes the total length, which is considered to be 15,000. Now on this node here, I'm going to import the signal into a signal analyzer. So in order to go to the signal analyzer, here with, I'm going to open that app, signal analyzer app. So into the signal analyzer app, but prior to that, as you see here, I think it has not executed. Just give me a moment. Let do that. So that in the workspace, the signal will get loaded. Yeah. And out of all, those 15,000 samples I have taken there. So now in the signal analyzer app, we are going to, yeah. Now the signal, First of all, this is the Signal Analyzer app, and here with you could see that there is an analyzer menu, then the display, then time and the measurements. So we can easily do the analysis in both time and frequency domain. Initially, I just select a single grid here in order to visualize this ECG signal. So hope this is visible, and we can just have a look at a smaller portion of this ECG signal with a few of the cycles, I would say. So with the help of panel, we can observe our signal, and hereafter in the signal in the spectrum, you can also observe the spectrum of the signal. So in short, I would say that in case of writing the commands in the program, here with directly by the pick and place kind of say the way out, here we can quickly observe and get to know what are the we can say the contains or the signal say the parameters or the spectrum based say the characteristics corresponding to that signal. Now I'm closing the panel. But now once you observe this ECG signal and its spectral visualization, well, before that, here with I'm changing the x-axis in place of the samples. I'm considering here the sampling rate and the starting time. So that now as you observe in the spectrum here, it's clearly been visualized that there is a power line interference of the value that is 16 Hertz, and this needs to be suppressed, this needs to be completely removed. Now we all know that the way how to do that is through the analysis of the signal, by means of pre-processing, and then by means of applying the bandstop filter, so that this particular, say the peak, the power line will get suppressed. And for that, I'm just selecting the bandstop filter as a selected filter. And since that single instance or the single frequency value is to be eliminated, so for that, with a very narrow band, here with the lower pass band, I'm selecting as a 59 Hertz, and the upper pass band is selected as a 61. Then here with you can also change the stop band attenuation, user can change it, and just by means of doing that, we'll get the filtered signal. Well, now the case is what has happened that it has overwritten actually our earlier ECG signal, and now on here this is basically the filtered signal. So all that I could do is, otherwise I can once again import the signal as the original one and I can overlap with the filtered signal. So I can change its name as it's my filtered signal at present. And through the display grid, you can also have a multiple windows, and likewise, I would say the parallel way you can have to visualize the original signal, the filtered signal, and hereafter doing the other set of say the processing, you can parallelly observe the visualization onto those signal. Now, another point of observation here with is that in this particular signal or the ECG signal, we are also going to apply the detrending. You all know that as you could see here, it is shifted from say the zero reference, that's the baseline value, and for this reason, we will be performing the detrending. And to do that, here with I have copied down our say the filtered signal, which was the say the initial signal, and I'm just renaming it to call it up as a detrain. And onto this signal now, detrain signal, here, just from this pre-processing option, we'll apply the detrain. Now, in order to visualize both of them separately, I'll make use of this grid selection. Now let us visualize it here. So I'll select this grid to just observe the detrained signal, and this one will only be, the first grid will only be indicating the filtered one. So hope the difference is clear over here, that the filtered signal was shifted from the baseline, and here is the it is arranged, or that baseline effect or the wandering, that effect, it has tackled very well and shifted with reference to the zero. Now this detrain signal, it also contain here with the say some low frequency noise, as is observed from this particular signal. And in order to remove that low frequency noise from this detrained signal, now we are going to export the signal to the workspace, and followed by that, you can see here that the signal has appeared here. Now I choose web from the app, because that is again the form of say the filtering operation what we need to apply. And the type of the filter here we would select as the wavelet based analysis, and for this reason we'll be selecting the signal multi-resolution analyzer. So now it will open up for us this signal multi-resolution analyzer, and I'll import the signal from the workspace, which is the detrain signal, into the multi-resolution analyzer. So this is the by default setting where it is using this discrete wavelet transform, and these are the type of wavelets, the basis that it supports, from sense to the coefficient and the Daubishes. So we can choose, we can select even without writing the code, and we can analyze by visualization. By the way, I just forgot to mention that once we have completed from the signal analyzer app the operations, then from the analyzer, by choosing that particular operation, we can simply say that generate the function, and it will generate for us based upon what states we have executed onto that particular signal, the MATLAB script. So that's the, I would say, the beauty of this app utility, basically. So now it will generate that function for us. Yeah, this is it. So since we have simply performed one state, states like filtering also, detraining also, and again there can be a few measurements also. So accordingly, it will pass on to us, it will return us the function containing all the multiple states that we have enacted. Now, continuing with the multi-resolution analyzer very quickly, here, basically, you could observe our aim is to, filter out this low frequency noise. And for that, here we got these options that we can take a try of, that is the different wavelets, then the numbers, and the decomposition level. So here in the level selection, you got an option that is whether to include all the levels and to show it up or not. So depending on that, we display those levels, their corresponding relative energy and even frequency. Because we all know that the multi-resolution, in the multi-resolution analysis, where with the wavelet we apply, basically it does the decomposition of the signal into the approximation coefficients and the detail coefficients. Approximation coefficient, they are the low frequency coefficients, and the rest, the detail coefficients, are the high frequency coefficients. So that comes from the fundamental of the wavelet transform, or the discrete wavelet transform, and here we are directly applying that knowledge using this utility. Now we could clearly see that here with the signal to be eliminated is the low frequency signal, and which is being observed in this particular plane, the reconstruction plane, I would say, or the display. And this approximation coefficient, which also contain that high frequency, but for that high frequency component is the signal of rest. On the biological signal or the biomedical signal, it is very important that we should not be disturbing or altering the basic information. So we have to be very cautious while doing all these signal processing operations and typically handling the very low frequency components over there. So over here, now what I'm doing is I'm keeping the default wavelet, say the wavelet type of the wavelet family as the same. Number you can change as per your observation, as per your requirement, and level I'm now increasing and decomposing. I'm just trying to observe what happens like. So supposingly now, if I remove or if I just remove this approximation coefficient, to much extent actually that low frequency noise has gone, and still we can try it up by increasing the level, which will not which will not affect our original frequency contained. And from this approximation coefficient, we could see that now this is the low frequency, actually the coefficients or the components what we are supposed to eliminate or what we are supposed to remove from our say the detrended signal. So this is the way out by changing the different types and the different combinations, which you can sound quickly with the selection of the wavelet and doing the reconstruction basically. This is the decomposition level, and here it shows making use of the selected levels, how the reconstructed signal will appear. Now in hereafter, now I would like to take a third, I would say, the demonstration, and that is for the signal labeler app. So again, I'm going to this signal processing and communications, the app library, and from here, I'm choosing this signal labeler. Then I will open this signal labeler. Take a moment to pop up this window. Yeah. Well, now from here, I'll be importing the signal which I would like to label. So signal labeling, as mentioned before, I'm just making use of the deep trended signal because it is filtered also, and we have done the deep trend process also. So I'm selecting this particular signal from the workspace. Well, now in this particular, I would say the app, herewith we are going to add the label definition basically. In the label definition, we have imported our sample. The label that we are going to apply, why the labeling is so tedious, because as you could observe here that this is a single signal what I have taken as an example, a single file. But actually in the database, even for this database, it comprises of basically 210 MAT files. And when it comes to even from the ML to DL, when we move on, so we have thousands and millions of such data records, and when they are not being labeled and when they are to be labeled, say either by writing the customized function or even by say the experts by observing them. So that's really become a very, very tedious task. So over here, I'm writing this label name as, I'm labeling it as ECG regions. And now in the label type, we have got two choices, that is either ROI or a point. So initially, I'm just calling it up as the ROI, and I have the label descriptions to be, say I have a label P, since I'm going to mark for the three regions, that is P, and then say the QRS, and then thereafter the T region. So this is just a description basically. So we are going to write this for ECG signal. That's it. And the data type that we are selecting here is the category, because we have three different categories out here. So the categories, I would say the QRS, and each is to be entered on the new line. So it's a QRS, then it's a P, and then it's a T wave. Yeah, so that's it. So initially we have done this. So now after that, here with again in the display, you can see a display pane is provided. And since we are doing the labeling, initially I just select some say a shorter duration so that I can independently have a look at and tag those particular regions by an appropriate labels. So after doing that, from the labeler, I'm simply going to say default it has selected the value as a QRS, P or T. So let's say we are selecting QRS, and here with by marking up this region, and which you can easily shift depending upon. Yeah, now here comes a bit of expertise uh, in terms of understanding, not expertise as such, a bit of know-how, because it's an important step when it is being used into a classification like application that will matter if it goes wrong. That's why this is to be done with caution, and this is particularly in a manual way what we could do. And once we are done with this particular, for one signal, we can also apply the same by just writing the loop there. Taking this entirely as a, as an entire package or as an entire data set. We can here with import an entire data set itself, and to all of them we can, yeah, we can basically label. So now after this, display time, even this timings can be noted or can be automated, and we can get those timings. Say, okay, this is done. Next, I would take a P wave and say draw labels. So yeah, right now I'm just marking up a bit tentatively just to give an idea that how come, this is a bit overlapping and this I would like to move like. So yeah, this is my E wave marking, and at last I'll also select the T wave or the T segment. So yeah, that's the way actually how we could label for one signal. And like this, we can extend it for the others as well. Well, this we did for the ROI based type. Now, supposedly that I would also like to mark the say the R peaks, because that is also one of the important tasks. Like, so here with what I'll do is I'm adding here the label name. Let me take it up as say the R peaks. Now, since those are the peaks, so I will consider the attribute as a point. So yeah, that is it. Here the description, you can say it like the R peaks itself. That should be a description, and yeah, that can be simply logical. So this is being a R peak, and since we have taken it as a logical, it simply will have a value like a true or false. And now we will mark this R peak manually. So the first one, the second one, because we know well that the R2R peak measurement is also one of the important tasks for say knowing the condition about the ECG signal. So yeah, this is the way how the labeling could be done manually. Hereafter, once we label this data, then we can export this entirely to the workspace as simply the labeled signal state. To the workspace directly or into a file also you can export. So this is how I've exported now this labeled signal state into a workspace, and let's see how it appears to be. Just allow that timing. So yeah, it has appeared here in the workspace, this label data set. So this has appeared as an object. It's taking a bit of time to pop up. Let's try. So yeah, this is how you could see that that's the labels, the table. Since we are running in a line mode here, it's taking a bit of time. So you'll find that all the say the PQ, the P wave, and the QRS complex. Now it has label for the selected cycle, which we can extend. So that's the way out how it has shown the labeled data to us. So now with this, I've completed the demonstration for this ECG signal and the three different, I would say the app modalities which are supported there in the MATLAB. Now in the remaining time, I would like to take another demonstration over here. Ma'am, I have some time, some more time, no? 10 minutes or so. Hello. Hello.
Yes, madam. You are ready. Yeah.
Sorry. So now I'm just switching the screen, and this is a very interesting tool actually. So when we start for the first time, you can just type in there for the Age Impulse Studio, and this is the very first hit in the search what you could find the Age Impulse. It's basically a development platform for the machine learning onto the edge devices porting. So I felt this will be one of very appropriate demonstration here, so I've selected this. So presently, I've kind of come up with the half-baked thing here. So the dashboard of this Age Impulse, it appears just loading. Now I will have to use the mobile phone also. So the thing is, this is the dashboard actually for the Age Impulse, how it appears to be. And as I mentioned, this is completely a kind of a tool or a package, and end-to-end, where we can start by actually capturing some data, particularly through the say the accelerometer, the say the microphone, and also through the camera. And one of the, I mean, we all have this mobile phone with us, which is equipped with these basic sensors basically. So initially, the dashboard when it appears, you need to sign up for the first time since I've already done so. So with this username, then we can start with our new project. So now I have labeled this as a motion classifier project, so which you can edit, and even the description for the project you can type in as per your choice. Then let me introduce to the left hand pane here, which comprises of first of all the dashboard. Thereafter there is devices option, and in the this is the devices option. And here with I would like to connect my handset, the mobile, in order to real-time capturing that. Then we have the data sources actually, and different we can import the data sources basically from the cloud as well. Then this is a data acquisition, say the selection, and in the data acquisition, we can actually record our own data. So partly I have completed with the recording, which I'll show you here now, how to go with the recording. So once you record the data sample by sample, here you can also observe through the, say, the waveform of that particular data. Then thereafter, once we acquire the data, then it goes to the impulse design. And in the impulse design, these are the different, I would say, the menus actually, where since the work that I'm going to demonstrate here is about the motion sensor and then the classification for those different type of the motions. Hence, in our case, this is the time series data. So it will come depending upon what is the type of the data that you have acquired. Thereafter, then it performs the processing. Now, this processing block, whenever you start from the scratch, you can just click on and you can do a selection actually, which type of the processing do you want to apply. So at present, I just selected for by clicking up an add, I selected simply the spectrum analysis, other options as well. Then after this second step, we go for add a learning block. Now here comes the machine learning aspect of it. So when I say add learning block, as you could see here, there is different type of, say, the classifiers or even the regression algorithms which are supported. So here, let's say the classification or anomaly detection, custom classification, all these are the options which are supported. So you just have to say add and it will add it for you. And after doing that additions, thereafter we click on save impulse. So initially I'm just introducing the entire dashboard and the different contents into it, and thereafter we'll see the demonstration. Then once we are done with this, we can get back to the dashboard, and here with we can deal with our the data set. That is, as you all know that in the machine learning class, we are going to, first of all, we are going to perform the data preparation. In the sense, we are going to split up our data for the train and test set. So here we will go for that train test splitting of the data, which here with to some extent it is doing it directly into 80/20, or else we can do that manually as well. And then thereafter, once it has been done, we go for, say, the model testing. So with this particular, say, introduction, now let me start here by first of all connecting the device. So I'll just say that connect the device. So presently I'm selecting my mobile phone. So yes, we'll ask simply to scan the QR code, and here with I've done the scanning. As you could see that it is scanning there. So just by tapping, so it will ensure from your mobile screen also that this device has been connected. Now after doing that, now we go for data acquisition step. Now in the data acquisition step, basically we need to decide, let me also tell, presently we are only going to utilize the accelerometer sensor from the mobile, and for that, since it's an accelerometer, there can be different motions. So motions and the labels selected over here, which you can change also. I've selected here 3 different forms of, say, the classes. One is an idle state, next one is an up-down state, and the third one is the left-right state. So let me do it for you. And here we have selected only the accelerometer. And keeping some of the say the sample length and the frequency at which it will be sampling as a default, I'll just start sampling. Now I've kept it. Sorry, this has been mislabeled. I should have done the up down. Okay, I'm doing the up and down motion. But supposedly, I mean, if it has not gone correctly, as you could see that for some time it was idle. I could check and I could decide whether to retain that particular sample or we can discard. So what I'm doing presently is I'm just discarding because I'm not satisfied with this particular sample. We'll delete that. Well, I'll start with the first label, and that is the idle label. Right. So with the idle label, then I'll ask for say start sampling. So yeah, I've just kept it idle. And it is going to sample it for 10 seconds basically. We can also confirm, as you've seen there, that we can also confirm whether we should, that particular label and the corresponding position is really gone well, is correctly being there. So as you could see, since there is zero motion or no motion, this is really a idle state. And actually, this is the way how you could start collecting your data. So for more and more time. The next state that I am taking up is up down. So for this up down, now I'll simply click on for the start sampling. And yeah, this is say the up down sensor, the up down motion. Just you could see it correctly. For this reason, I'm doing it in front of camera a bit rapidly. Now, whether I should, again, agree upon to this particular motion or not, that you can visualize, you could clearly see that, yeah, there is this up-down form of a motion, and I think we can go with this particular sample. The third type of, say, the signal that we will be capturing from the accelerometer, say, is the left-right. So, yes, let's sample this for 10 seconds. You see, I'm just doing a left-right sampling. We can wave it, we can do some, other form of, say, a circular motion or so on. So, that's the way it has done. And again, we can confirm it, that it's a left-right, yeah. So, I could say that some of the intermediate cyclic form of the motion has also been added, but that's fine. We can go with this particular data. Now that we are done with the data collection or the data acquisition, I think this is also a time, at this moment also we can get back to the dashboard for the splitting up of the data set. Because I had in my data set some prior data and some new samples I have added upon. So I'll go for performing trend test. So they'll ask me to perform the trend test split. Then for the sake of confirmation, I have to type it up. So I'm doing that. That perform split. Let's do it. So it has once again from its original state, it has done that trend test split, which you can observe here. In the sense, now this particular 3 minutes 10 seconds. Now, yeah, as you could see that there was some earlier data also, which initially I have made use for trial purpose. So it is just adding upon all the length, which is in seconds basically, which is in seconds. And for this reason, here this is a total timing for training, and that is 3 minutes, and this one is for testing, that is 2 minutes, and so on. So this particular bifurcation, this software, the tool has done on its own. Then these are the three classes: idle class, then up-down class, and left-right. Now here also we can check it up that whether our data set is balanced or not. That's also a way out. Now after this step, I'll go for the impulse design step. And in the impulse design step, now this already has come up as a time series data. Then I'll just check upon the spectrum analysis Well, this we are doing for sake of spectral analysis of this time series data. For this purpose, we have selected the processing block to be the spectral analysis. So by default, it was not present. Then I have selected and it has come up. Thereafter, I have selected the option from the learning block as the classification operation, where with the classifier you have selected as a neural network classifier. So this being commonly known to everyone, that's why the neural network is being selected. And you know that the features here, the output features, there are three classes basically: idle, left, right, and up, down. So with this arrangement, we can simply say that save impulse. Once we do that, we can actually observe. Here comes our the spectrum analysis part. So here you can actually see that we have now all the combined data with us. We have these three labels, and then we have these many, the samples. And for each of the samples, initially it is showing the raw data in this display. It's also showing these are the default, say the raw features, what it has extracted from this, and then thereafter, in the spectral analysis, what it has done is it has actually, filtered out that raw data. So, depending upon, the type of selection, I mean, we can change here. We can play around with this parameter, selecting the low or high pass filter, then say the cutoff frequency, the order of it, then the FFT length. All these we can, we can change upon. We can do it by trial test. And here with I'll do some. I'll check upon if it is up down. What exactly does it show? So this is for the up down, and with the default setting, it is filtering out that say that signal, and then coming up with the spectral features, because as I said here we are using the spectral features. So likewise we can observe in the sense, now this is the time, this is the step where with through visualization we can decide, and we can settle up with the settings, and then thereafter we can also see what the neural network classifier has done actually. So the neural network classifier, first of all, this is the neural network architecture, which you can change as per the, I would say, as per your choice. You can add some dense layers. You can add some extra layers. By the way, in the input, it has taken total 27 features. For the reason that we have here with in the spectral features, I must say that the save parameters, and yeah, here with I could say these are our total number of features. So which comprise of some energy part is there, then power is there, cutoff is, skewness, all these. So overall, these are 27 features. So this, 27 features what it has extracted, and then followed by that, we go for the classifier. So these 27 features, of course, you can select, you can cut it to those number of features. Here we have taken it as it is, hence by default, the 27 features have been selected, are considered. And then here with are the output layers, since we have three classes. I'll just quickly go through. And yeah, here with it shows actually the clusters for the three classes. I'll start training. Sorry, you could see here exactly the training output. Give me a moment. So we can observe the model training when it happens, and followed by that, you can also see the clusters, the groups corresponding to those three classes. We can also see if some of the class or some of the sample has been, say, misclassified. Now, since this being a training one, the accuracy it's showing is the 100%. Now, let us do the model testing. So as we have earlier seen, in that 80-20% of the splitting, this model or this particular tool, it has separated out and has reserved some data for the for testing purpose. So we will do the classification for the test data, and then we will see the live classification in the end. And as you could observe here, that the model testing, when it happens, the steps also are being displayed there. Just within a few seconds, it will end. So it is classifying with the help of an classifier. This is our model testing result, and for the test data, it has shown 87% of the accuracy along with the confusion matrix. I'm slightly speeding up. Ma'am, please interrupt me whenever I have to stop. I'll just take 5 more minutes, I think.
No issue, ma'am.
Sorry.
It is
So
actually
now,
running very nicely.
yeah, thank you. So now I'll go with the live classification. Now, live classification is once again through the device. So initially, I check upon whether the connectivity is there with the device. So that's why in the devices, yeah, I think in between it has disconnected. So once again, you need to scan it. I'm doing it through camera. Yeah, so it is scanning up and now connected. Of course, all this you can see on your screen also, the mobile screen also. Now I'll quickly go with the live selection. Now in the live selection, this is the real testing for this particular model. Of course, we can train, tune, do some hyperparameter tuning also. We can select different type of the say the classifier type and go for refinement of our model. Now I'm in the idle state. I mean the mobile, the accelerometer is in the idle state. And now this is the live classification. So it is trying up for this, and yeah, if you observe here, the recent one is the test sample actually for which we have tested. So as you could see that with 87%, it has classified it as an idle class. So likewise, we'll also check it with the other two classes very quickly. We have an up-down class, and I'm doing it for 10 seconds. The up-down, yeah. So this indication is also there on our mobile screen. It also shows here the process feature, the classification, and this is the recent one. As you could see that it has nicely classified with 99% of the accuracy for this class as the up-down one. And lastly, for the left-right. Anyone can, easily, try this up for your own kind of the different motion sensors, audio and video as well. In its documentation, there is tutorial being given. Referring to it, you can easily take it up for the different forms of the data. So for the left right, this is the recent result. It has perfectly identified as the left right type of the class. And alongside, you could see it's also showing its corresponding waveform and the clusters. The classifications, and in case if something gets misclassified over there in the best part of this particular tool is the deployment, because this is meant for an the edge device based implementation. So whatever I have shown you right here, we can download that model, and we can port that model onto our mobile phone itself. So wherewith now, thereafter, we don't require any cloud setting or say even the internet, and just by means of using our mobile itself, we can start using that particular model for an application of say a classification, audio classification, and so on. Just trying to change this. Just want to quickly show you here the model actually how it appears to be. And for that, in the end, I'm taking help of this Neutron app, or say the utility. Now what has happened in the downloads, this is the model actually, this EI motion classification. This model, it has given to us when I downloaded that. And by downloading, yeah, I have selected their 8-bit quantize, because now I think this is really a very shorter duration of time where this can be explained in that detail. But one can explore, because when it comes to the implementation, we need that the 8-bit quantized data type. So here with this model, what I have downloaded, you could see that so nicely. This is our model actually. Into TensorLite, Neutron is an app via which we can visualize the entire model. Presently is a neural network based, so it will show even the sizings for each of the layer, the number of weights, bias, and the type of the activation function it is using. In the end, it's using the softmax. So in short, this is an internal, say the model visualization, which can happen through the motion classifier. So in the end, actually, I have come up to the end of this demonstration. We must attribute to the MathWorks and various other resources which helped in preparing this entire demonstration part. And yeah, thank you. Thanks a lot for your patient listening, and with gratitude to Dr. Meeta ma'am, then Dr. Arvind sir, Thanki ma'am, and Chirag sir. Thank you. Thanks a lot.
It is really a fast marathon of your vast knowledge and vast practical field, ma'am. Actually, it is really give us the inspiration that if we are also working with MATLAB tools since many years, but the way that you have explored the things, it is really helpful for real-time applications, and people can do many things with this kind of application which is available. So it is really tremendous efforts and your demonstration. So 1 hour is really less for this session, and we definitely get your knowledge with some hands-on experience in offline session.
Sure, ma'am. Sure.
So, any question from students or participants? My one query is that if MATLAB as well as model sim that we are working, that actually in MATLAB system generator and model sim will give you the interfacing with the hardware devices, or on the simulation environment is with the editor window, but that we can do. So what other facility we can incorporate with MATLAB software, so that we can also make some interfacing with some sensor, or like a motion detection or facial recognition, something like that, apart from webcam or something?
I would say that Simulink is again one of the fantastic the utility here in the MATLAB. So using which different say the sinks I mean the different sensors and sources I mean to say the different target boards we can connect to. And yeah, since you asked it for the MATLAB, so yes, I think this is Simulink is one of the ways like. But other embedded targets also you can basically interface. And in the yeah, that's I have missed it or what. So yeah, when it comes to even deployment, I would really like to introduce to the participants that here also through this age impulse, starting with a basic Arduino, you can see that the different the STM based boards or even the RPi, the Raspberry Pi, the Nordic boards, this can also be interfaced. So I think this can also be further explored. So some pointers, I mean, whether I have shared my screen or I only, yeah, sorry. I thought I have shared, yeah. In the deployment option here with, you could see that you have all these boards what you can interface. So this is again a thing actually what one can give a try. But yeah, to answer the main question, via Simulink you can do. And of course, the FPGA boards can also be interfaced.
Styling system generator facilities available with MATLAB, so that we can do.
Yes. And embedded target boards.
Yeah.
And DSP processors.
Yeah. Processor also.
That is also a way out that if you have the cross compiler, then directly by generating the C programs, the DSP onto the DSP processors also we can put the codes and make the real-time implementation. And there are some add-ons what MATLAB has come up with, to my knowledge, like the Raspberry Pi and all of the, even the Jetson Nano. With all these kits, the MATLAB has that cross-compiler feature, and we can, interface that.
Like advanced version of MATLAB, these facilities are available with advanced tools as well as advanced algorithm in DL and ML.
Yes, madam.
That would be possible. Yeah. Okay. So thank you very much, ma'am, for sharing your knowledge. And as a token of love from our side, I would like to represent eMemento. So kindly accept that.
Yeah, ma'am. Thank you so much.
If is it possible that you visualize my?
Yes.
Okay. Thank you, ma'am.
It's getting shared, I think.
It's on the way.
Thank you. Thank you. Yes.
Okay, now I would also like to announce our quiz winners who are actually participating since 3 days. So I would like to announce our third winner of the quiz. So I think it is visible to participant.
Yes.
Okay, so Dia is the third place winner for our quiz, which has been organized during these 3 days. So congratulations, Dia, for securing third position.
Congratulations.
If anyone can take the snapshot from my side, then it would be. Mita ma'am, can you do that favor?
Yeah.
Okay. So thank you. The second position winner is Hemant.
Dia is there, so she can turn on.
Yeah. If Dia can turn on the video, then it would be great.
Mm.
Is she available?
Okay, move ahead.
Second prize winner is Hemant. He has secured second position for quiz. And
Dia is there. Yes.
okay. So just we take the snap with Dia. Yeah. Okay. Now second position winner, Hemant. Is Hemant present? I don't think so. Okay, he has been there. And the first position winner is Divanshi. She is from SCAT Engineering, and I think she might be here. Divanshi, if you can open your video. So, congratulations to all the quiz winners. Before ending of the session, I would like to thank our student branch volunteers who have done a really great job, and they have done really appreciable work within a short span of time. I would like to also thankful to all the speakers who have actually accepting our invitation with a very short duration and presenting their knowledge in a very nice manner. So I would also like to thank all the eminent speakers who have delivered their talk during these 3 days. I would also like to thank both the faculty members associated with the GSET IEEE student branch and the SCAT IEEE student branch for their valuable efforts and support. I would like to thank Mita ma'am and Arpan sir and Chirag sir for always be there as a team for coordinating this event. I also want to thank many other person like our student coordinator Abno, Muskan, and Takshil, who is working with their academic schedule, and after that they are also managing this event very nicely. And all the participants all over the India who has participated, thank you very much. Your feedback is always improvise our program in future. So thank you one and all. If you want to share your experience during these 3 days, any one of you can share your experience.
I want to share my view.
Yeah.
You have not added your name in acknowledgement. I would like to acknowledge you for your hard work for these 3 days business school.
Thank you. Thank you. Mary.
Good job.
So any participants who want to actually or any coordinator, students volunteer or coordinator.
Muskan is there.
Yeah, Muskan Abno is there. They can also share. Abno?
Muskan is the head also.
Yeah, Muskan.
So it was very difficult for us actually, sir, to manage academic as well as this session in whole online mode. But it was a very nice experience as we learned many things from this situation, how to handle such situation. As a team, I have now and Takshil coordinated very well and managed this nicely, I think.
Where is Abno? Abno want to say? Because he is always backstage, just never come in front. So Abno, can you please share your views?
Ma'am?
Yeah.
Good evening, one and all. Yeah, it was a great experience, and we had done so many events, but during the academics and after the college, coordinating the event is such a difficult thing, but we had tried to do, and I will be thankful to you all, Meeta ma'am, Chirag sir, Thanki ma'am, and my coordinator friends, Muskan and Takshil. Yeah, thank you.
So Hemant sir is there. Sir, congratulations for quiz winners. We will definitely share with you your quiz winner memento. Dia has written one thing that as I am in the first sem students, then also I came to know all the information as all the professors taught in very good way. So that is also very
Good.
yeah, remarks for us that at least they can understand what is covered. And one appreciable thing from these 3 days I have also learned, that is every speaker has maintained the theme, as well as they have also started with basics then they have approach to application. So it is really helpful to UG PG students who have entitled to means they have to start something in this domain. Then at least they come to know from where they have to start. So it is really very good experience from student point of view as well as faculty point of view, that we also come to know the flow of presentation. So it is really nicely maintained. Last but not the least, I would also like to thank all the session chair who have also contributed to the session for maintaining the session very well. Thank you all IEEE team members who has provided our WebEx links for conducting this session. And also, we would like to apologize for yesterday chaos due to some technical glitches of WebEx link. We have shifted to Google Meet, and all the speakers have also nicely coordinated along with participants. So thank you very much, one and all. And we also hope that in future events, you all are there as participants or as victims of that events which we will be organizing in future. Thank you, one and all.
Just want to acknowledge Ashwini madam, you have introduced a very nice tool to the students, even to the participants, even those who don't know about the coding, they can also directly utilizing their idea and test it and verify it on the model. So they can go for a further process after that. So really, it was a very nice session.
Thank you. Actually, you've given the opportunity, and I too have, enjoyed preparing this for the audience from this perspective, because as per the theme given.
Yeah.
So that made actually.
Definitely. So hope to see you in future also.
Yes,
Sure, ma'am.
Once again, thank you.
thank you.
Thank you.
So, good night, one and all, and thank you very much for providing your valuable feedback. Thank you.
Good day. Good night.
Good night. Thank you. Yeah.